In this video I'm going to look at the construction of a parabola. This is just a random question here from the junior cert higher level paper, where we're given a curve here, ABC, that we assume is a parabola. And a lot of people looking at this question would draw the construction of the parabola with the vertex at B. Now the key point when drawing a parabola is to establish the location of the vertex. So in the text it will always tell us which one of the curves is a parabola. Of course you can normally tell that by just looking at it. And here we see that the curve AB is a parabola with the vertex A, which is the opposite of what most people would have thought looking at it. They would have assumed the vertex was at B. So the vertex up here is at A, which changes not the construction itself, but how we set it up. I've just drawn something similar here on the board, where you can see I've allocated point A up here as the vertex. So our curve, just the same as in the 2006 question, is going to come down here, and then it's just going to be a mirror image down in the second half. A lot of people would have assumed that it was just one single curve. The next thing I've done here is just divided that line along the top here into 5 equal spaces. You can use division of lines. Because I've chosen a measurement of 150, it was easy to just go along and divide it into 5 equal spaces. I've then just divided that line into 5 equal spaces as well, using the division of lines construction. Now if you're not sure how to do that, I have another video on this channel which will show you how to do division of lines properly. It's a very useful and common construction. The next thing we need to do is join each of these divisions down to the vertex. That's why it's so important to work out which point on the curve is the vertex, because we're joining all these points down to the vertex, and obviously if you chose the wrong point, the construction is completely wrong. So I've just joined each one then down to the vertex, and I'm going to use these lines to find the points along the parabola. And it's fairly obvious if you just take a look at it where the points are going to fall. Okay, if you look at just the first line there, it's going to cut the first line here, and then you can guess at the second and the third and the fourth. Okay, so you're getting your idea of your curve coming down to a point there. So just drawn it in there, okay, with the curve going down to the vertex. Now if you remember back to the 2006 question, you can remember the point was there, that's the point B, and we just then reciprocate the same curve down below to finish out the question. So the handy way to do it is just use the same construction as you would use in axial symmetry. So just left one arc there that you can just about see it. You put the point of the compass here, open the pencil out to there, and just swing the arc right down till you cut the line coming from the original point. Move the point of the compass to here, pencil out to there, swing it round, do the same on this one, and then finally on this one, and then join them up. And then we've got our curve A, B, C, which is actually the mirror image of the same curve. So just to finish it out then, that's A, B, C, with of course the vertex at A.